Welcome to today's class on angles on parallel lines. At the end of this class, you should be able to solve problems of this nature, questions that are on angles on parallel lines. But before we go into solving problems, let us talk about the keywords, some of the things we should have known before this class. So let's quickly have a quick review. Corresponding angles. Now, first, we know that parallel lines, there are two or more lines that will not meet even when extended. So we use these arrows to indicate that they are parallel, right? So when we have two or more parallel lines and a transversal line, so a transversal line cuts across parallel lines. So identifying the corresponding angles, we know that corresponding angles, they occur on the same side of the transversal line and they are equal. So if I have this angle to be A, let's have this to be B. So we say that A is equal to B because they're on the same side of the transversal line. So for better understanding, see it as I have for the top, I have it like this. Now the bottom, see the bottom, it's like this. So you see they're on the same side, like on the same position. So if this is A, this is B, you see they're on the same position. So A is equal to B. This is for corresponding angles, right? Now, let me make this to be X. So which position do you think corresponds to X based on what I've explained earlier? So this position corresponds to X. Let's say that is Y. So we can also say that X is equal to Y. What's the reason? It's they are corresponding angles and they are equal in size, right? Okay, one more. Let's say this is F. So F corresponds to G on the same position. So that's for corresponding angles. Moving on, talking about alternate angles. Alternate angles in parallel lines are angles that occur on opposite sides of the transversal line, and they're also equal in size. So for alternates now, we have these parallel lines. Don't forget, I have my transversal line. It can go this direction. That's my transversal line. So let's say this is P. Now it is on the opposite side according to what I have here. They are opposite one another. Sorry. It occur on opposite sides of the transversal line. So this is P and this is Q. So one thing you should know about alternate angles is that it appears like the letter Z. So something like this. It may be in this form or this direction, or it may be like this. So when you see, don't forget this is parallel. These lines are parallel. They are parallel lines. It may come this way. So this angle here is equal to this angle. It's alternate. This angle here, alternates. Right? So this alternates. So that's one way to identify alternate angles. So if you carefully look at this part, you see this part. So the angle P is alternate to angle Q. So that's for alternate angles. Right? P equal to Q, alternate angles. Yeah. You can also look at it. If I want to look at it based on this, let's call this A, let's call this B. Right, so this, let's use this. So I can say that this here, this angle here, angle A, is alternate to angle B. That is right here. So that's another alternate. And so I can say that A is equal to B because they are alternate. All right, moving on to vertically opposite angles. So they are opposite one another at a specific vertex, right? And they are created by two straight intersecting lines. Now, for example, I have a line like this, I have another line, they are intersecting. Now, this is the vertex. So I can say that this, let's say this is C, vertically opposite, right? So this D. So I can say that C is equal to D, right? If this is E, angle E, the vertically opposite, this is So E is equal to F, vertically opposite angles. They are equal. Right, so one mistake many students make is you have something like this. Now look at, I have something like this. I have another one like this, like this. Now do not make the mistake of saying this angle here is equal to this angle. No, it is not. Now let's say this is A, this is B. A is not equal to B. Because you see that this line is supposed to continue, it's supposed to be a straight line. Right, it's supposed to be a straight line. So at this point, we cannot say that A is equal to B. No, it is not vertically opposite. All right, so moving on real quick. The sum of angles on a straight line. So we know that the sum of angles on a straight line is 180 degrees. A quick one on that. I think I can do my this. Right. So a quick one on sum of angles on a straight line. So if I have this is a straight line. Let's say I have multiple angles. If this is A, B, C, D. So all of these angles, by the time we sum up, A plus B plus C plus D, we say that it is equal to 180 degrees. So that's another thing we'll be using here, right? So if I have my parallel lines, like I have here, this my parallel lines and my transversal line, right? If this is A and this is B, so I can say that A plus B is equal to 180 degrees. We'll be using that as we solve other problems too. A plus B equal to 180 degrees. The reason is because the angles on a straight line. Okay. So for the vertically opposite, I didn't show that on a parallel line. So for the vertically opposite, this is A. Now, if this is, let's say this is D, for example, I can say that A is equal to D. Right. So the reason is it is vertically opposite. I didn't show that vertically opposite. Yeah. So, all right. So sum of angles at a point. Let's have this to be equal to E, right? So this, we are looking at this point. So we know that A plus B plus D plus E gives us 360 degrees. It's going to be 360 degrees. Angles at the points. The same way, if I have it as if I have this place to be X, Y, P, Q. So we know that X plus Y plus P plus Q is equal to 360 degrees. All right, so this is just a quick review on the things we should have known. So let's solve problems. Example. So we have to find the values of the marked angles. So based on what we have learned, right, we can use different approaches to solving this problem, right? But the major thing is we know that whatever we are using is accurate. First, we can say that X is equal to Y. Looking at what we have learned, why? Can you remember why? Why is X equal to Y? X is equal to Y because it is vertically opposite. It is vertically opposite. And vertically opposite angles are equal. Okay. Also, we know that we can also say that A is equal to Y, or we can say that Y is equal to A. Why? Why is that so? Okay, can you remember? Corresponding angles. And we know that corresponding angles are equal. This is G, corresponding angles. Okay, and I can say alternate angles. That is X and A. So it forms something like letter Z. So it's something like Z. Right, so we can say that A is equal to X. It is alternate angles. Okay. Okay, so having known this, let's say, how then do we use all of these things we know to solve, right? I can decide to say that Y plus 115 degrees equal to 180 degrees. Why? Okay, it is angles on a straight line. So I will know that the sum of angles on the straight line is 180 degrees. So or we can say that x plus 105. Oh, sorry, 115, or we can say that x plus 115 is equal to 180 degrees. And decide to do that. We'll have the same thing. Okay, so let's use x. So x is equal to 180 degrees minus 115 degrees. So we can say that x is equal to 65 degrees. X is equal to 65 degrees. Now, based on what we've said earlier, if x is equal to 65 degrees, and we say that x is equal to y. So if x is equal to y, therefore, y is equal to 65 degrees. And also, we say that x is equal to a, or a is equal to x, alternate angles. So we can also say that a is equal to 65 degrees. So that's for the first question we have. It is that simple. Okay, let's move on to the next one. Now, this is straightforward. What do you think, what concept are we using here? X, Y, Z. We have been told that X, Y, Z is a straight line. So if X, Y, Z is a straight line, now we have angles on a straight line. So we know that sum of angles on a straight line equals 180 degrees. So we can say that the angles we have, x plus 4x plus 3x plus 2x is equal to 180 degrees. That's, angles on a straight line. On a straight line. Okay, so solving this, x plus 4x is 5x plus 3x is 8x plus 2x is 10x. So 10x equals 180 degrees. Dividing both sides by 10, so x is equal to 180 degrees divided by 10, which is 18 degrees. Therefore, we know that x is equal to 18 degrees. Moving on, these are concepts that we use in solving angles, right? Questions that has to do with angles on a line, angles on parallel lines, like question 1. So let's look at number 3. We are told that PQ is perpendicular to QR. Now, I need us to know that, or to remind us that it can be written like this. You may see it written like this, PQ. Then you see this symbol, then QR. Right? Oh, I think the symbol is not written properly. We have it something like this. So when you see this, it shows that PQ is perpendicular to QR. It may not be spelled out like this. And parallel lines. Oh, okay, I think we'll get to that. So, given that PQ is perpendicular to QR, we are to find x in the figure below. All right, so one thing we should know is that perpendicular lines makes 90 degrees, or makes a right angle, So if I have this, and I have this, so it makes a right angle. So these lines are perpendicular, right? It can go the other direction. You can have it this way. It's a straight line. It's perpendicular, right? Or we have it this way. But we will be told that these two lines are perpendicular. We don't just assume, right? The information must be given. So if PQ is perpendicular to QR, this is perpendicular, this PQ is perpendicular to QR. So it means it forms 90 degrees. And what that means, that is, all of these angles there should be equal to 90 degrees. That's what it means. So in that case, if we sum up the angles, we have 90 degrees. What are the angles? X, oh, sorry, this is 3x. So we have x plus 3x plus 2x. It should be equal to 90 degrees. X plus 3x is 4x. 4x plus 2x is 6x. So 6x is equal to 90 degrees. X is equal to, we are dividing both sides by 6. So x is equal to 90 degrees divided by 6. So 90 degrees divided by 6 is equal to 15 degrees. So it means that x is equal to 15 degrees. This is PQ. This is PQ. Okay. So questions like this, they may come in various forms, but the concept still remains the same. All right, question 4. We have question 4 right here. Now, look at it. It may be appearing a little bit confusing, but there's something I would introduce here that will make it simpler. In a given diagram, AB, now what this means, AB is parallel, line AB is parallel to line CE. So it may not be written, and you can see the arrows are not there. So when you see this, it shows that, or it says that line AB is parallel to line CE. We're asked to find X. Now there are various ways to go about this. So one of the ways we can do this is, I'm going to introduce another parallel line, right? So let's do away with this first. I know there's 280 degrees, but let's do away with it first so we don't get confused. So I'll introduce another parallel line. Let's have it this way to make it easier. Now with that parallel line introduced, right? Let me bring in some angles. Let's bring in some angles. I decide to extend this. I'll extend this way. Let's extend it so I don't get confused. I'll put this to be this angle here. That angle. Let me call that angle A. So from what I've done, if that is A, I can say that angle A is equal to 50 degrees. Why is that so? Can you remember? It is alternate angles. So A is alternate to 50 degrees. So A is equal to 50 degrees. Now, A being 50 degrees, let me bring in something else here. Let me bring in B. Let's say this is B. So if A is 50 degrees, and we know that A plus B should give us 180 degrees because they are angles on a straight line. The parallel line that was introduced. So the angles on it is A and B. So A plus B gives 180 degrees. Let's have that written. Angles on a straight line. Okay. So in that case, remember A is 50, that is 50 plus B equals 180 degrees. So I can say that B is equal to 180 degrees minus 50 degrees. So subtracting 50 from both sides. So B is equal to 130 degrees. Now there's something interesting here. Now do not forget that we have that this angle is 280 degrees. That is from this angle here down to this, all of this is 280 degrees. So if all of that is 280 degrees, let's bring it back. And B is part of it, right? So, and B is 130 degrees. So it means that these remaining parts, these are this left here, this part here, let's call that angle C. So we can conclude that C is going to be 280 degrees minus 130 degrees. Because B plus C will give us 280 degrees. That is, B plus C will give us 280 degrees. And B is 130. So it means C is going to be 280 degrees minus 130 degrees. So C is equal to 150 degrees. So we have C to be 150 degrees. So let's have it written. So C is 150 degrees. So C is 150 degrees, right? I can say I should be able to get what this will be. Let's call that D. We don't have a D somewhere. We know that C plus D is equal to 180 degrees, angles on a straight line, right? Angles on a straight line. So D and C is equal to 150 degrees. So we can simply say that D is equal to 180 degrees minus 180 degrees minus 150, and D is equal to 30 degrees. So D is 30 degrees. I could have just used that C, this C is alternate, sorry, yes, C is alternate to X, even without looking for D, right? There's absolutely no point looking for D. So we don't get, don't make it too complex. So we can say that X, we can say that X is equal to, we can say that X is equal to C alternate angles. Alternate angles. And or C is equal to X. So since C is equal to 150 degrees, that is X is equal to 150 degrees. I could have used a different approach too to solve that. Don't forget, I told you that different ways to solve problems, different ways to solve problems like this. Yeah. So let's look at this question 5. What concept are we going to be using? What concept are we going to be using for a question like this? Okay, so that's angles at a point. Okay, sum of angles around the point. Do not forget that sum of angles around the point is equal to 360 degrees. Now, if you draw a perfect circle, it's looking like a circle, or draw something like this. So we know that sum of angles in the circle is 360. Okay, so knowing that, we move further to say, solving this, 8x plus 4x plus 5x plus 8 plus 5x minus 7 plus, I'm going in the clockwise direction, 7x plus 11. All of this will give 360 degrees. And that's because angles are the points. Okay. So let's add up the like terms, right? So 8x plus 4x, that's 12x. 12x plus 5x, that's 8x plus 4x is 12x. 12x plus 5x, that's 17x. 17x plus 5x, that's 22x. Now 22x plus 7x, that's 29x. So we have 29x. Then let's add up the ones without x. 8 minus 7, that gives 1. Then 1 plus 11, that's 12. So 29x plus 12 equals 360 degrees. Subtracting 12 from both sides is going to be 29x equals 360 degrees minus 12. So 29x is equal to 360 degrees minus 12 degrees. That would be 348. So dividing both sides by x, we have that x is equal to 348 divided by 29. And that gives us that our x is equal to 12 degrees. So x is equal to 12 in this particular question, question 5. All right. So So that's it for today's lesson. So I'll leave you to attempt this question, right? Oh, it's not indicated. They are parallel. That is, this line that indicates with arrow, this line is parallel to this. So that's the hint we need. So we have to find x, calculate the values of angles marked with letters. So find x and y. All right, so I would like that you attempt this question. And let's see what you have. So see you in the next class. Thank you. Bye.